My project is the application of off-grid photovoltaics to rural China. First, I'd like to give you a general introduction about the energy problem in China. A non-linear regression analysis from Stanford University indicates that if China's GDP keeps growing annually at a rate of 8.3%, the biomass intensity would decrease by 7.8%, and the coefficient regression factor is 0.99, and probably a large part of biomass consumption contributes to the residential energy use consumption in rural China. In 1999, 65% of rural energy consumption for residential use stemmed from biomass. The energy per household used in rural area was 41 gigajoules, 4 times as high as urban energy consumption, which is 10.9 gigajoules. Those figures sufficiently manifest that the energy used in rural China is far less efficient than in urban area. A reasonable deduction is that the discrepancy of residential energy use efficiency between urban and rural China results from the latter's reliance on biomass. Furthermore, as it is known to all, biomass does not only have lower energy intensity than other alternative fuel types, but also it creates a great amount of greenhouse gases during the combustion process, which greatly contributes to the severity of global warming. In response to the problem above, I propose that a more environmentally friendly and more efficient energy should be introduced to the rural China, which is solar power. To be specifically, the application mechanism I recommend is off-grid photovoltaics. The reasons are 3. First is its necessity. The second is application. The third is benefit. In terms of necessity, like aforementioned, the people from rural China needs to have a paradigm shift in terms of energy use from conventional energy to unconventional energy, such as solar power. In terms of application, the off-grid photovoltaic design is physically applicable to rural buildings, since most of the buildings in rural China are in the form of single unit, which is house. Each household has its own roof on which solar panels are able to be installed. Therefore, each house has solar panel on it can be regarded as a standalone complex in terms of electricity supply and largely independent from the national electric grid system, which is so far not nationwide accessible. And also in terms of meeting the energy demand, the application of off-grid photovoltaics to rural China is very effective. If the kind of energy standalone complex mechanism is applied to all rural area in China, it would increase the capacity of energy supply in rural China by about 400 kilowatt-hour per meter square annually. And also taking into consideration that the building energy consumption in rural China is only about 3.4 kilowatt-hour per meter square. Thus, the off-grid solar energy supply far exceeds the energy consumption for rural buildings in China. Besides the applicability, the off-grid PV system application will bring about several benefits. The first is economic benefits. The off-grid solar power would bring about great economic benefits to rural China, assuming that the unit energy cost is $0.07 per kilowatt hour, which is the electricity price in 2004 in Beijing, and the average annual interest rate is 7%. The upfront cost of an off-grid photovoltaic is $1,500. The average capacity of an off-grid photovoltaic is 1,000 watts. The number of operating hours is 12, and the annual maintenance fee is 100. In a 10-year scenario, it turns out that the net present value of the investment is $58.74, and the energy cost saving is $4,447. The net energy cost saving is 2080.39. Therefore, the introduction of solar energy to rural residents in China turns out to be quite economically beneficial. Besides, the concept of off-grid photovoltaics application would create a great amount of green jobs, especially in the fields of solar material transportation and PV installation. Besides economic benefits, there are potential social and environmental benefits for residents in rural China once the off-grid PVs are introduced. If the cheaper and cleaner electric energy is accessible to rural poor in China, it would greatly improve their overall productivity, since they could consume energy at lower costs. They might want to extend their working hours to produce more. For students in rural area, it is the same story as it is in the production side. Students may extend their studying hours since they can access cheaper energy source. In terms of environmental benefits, since solar energy produces zero emission, so its environmental value could be quantified by the amount of carbon dioxide emission offset. The calculation methodology is that it is assumed that the project lasts for about 10 years. The annual solar energy supply from off-grid PVs in China is 400 kilowatt-hour per meter square. The rural building area is 24,000 times 10 to the 6th meter square. The off-grid PV operating hour is 12 hours per day. And also it is further assumed that if the energy is stemmed from a coal power plant, whose capacity factor is 80%, and the coal emission factor is 1 kilogram per kilowatt hour. Thus, the total carbon dioxide emission reduction in a 10-year scenario is 4.24 times 10 to the 7th kilogram of carbon dioxide, which is a very huge amount of carbon dioxide offset by the introduction of off-grid PV system to rural China. Besides the potential benefits, there could be potential problem as well if we introduce this kind of off-grid PV system to rural China. And the potential problem is the heating effect. Since this kind of project will be applied nationwide, so each rural household will install their own PV system, so it could create a huge heating effect in local communities. So in response to the problem, I propose two solutions. One is the application of a Spanish tile on the condominiums in rural China. The second is exterior landscaping and vegetation design. For the first proposal, because the Spanish tile is designed as curvy, so once it is paved onto the roof of the rural buildings, it will have quite amount of airspace, which will ventilate the air circulation and alleviate the external heating effect. Second is the exterior landscaping and vegetation design. So if we change the landscaping of rural China, such as planting more trees in the peripheral area, and kind of create a design that catch the breezes that go through those buildings and funnel those winds into the the buildings, and also it can have a alleviation effect to reduce the heating effect stemmed from the PV installations. That's all. Thank you.